Hello kiddos, today we're on 9-4 Angles of Polygons on page 242. The objectives here are to find the sum of the measures of interior angles of a convex polygon, to find the sum of the measures of exterior angles of a convex polygon, to find the measures of an exterior angle and interior angle of a regular polygon, and then to solve problems involving angles of polygons. Okay, so exterior angles are formed by extending the sides of the polygon. So it looks like this. If I'm going to go here, I'm going to do this in orange so you guys can see it. Right? That's extending the line. Okay? I'm also going to extend it from this one. Okay? Oops, sorry. There we go. Okay. Okay. An exterior angle of a polygon forms a linear pair with an adjacent interior angle of the polygon. So right here, this right here is a linear pair. Okay? So exterior angles are angles that are formed by extending those lines. So like over here, it'd be like right here, and right here, okay, right here. This interior, this adjacent interior, right here, and this exterior, right here. Okay? Keep that in mind. All right. Sum of interior angle measures of a convex polygon is going to be S equals, this is your formula right here. S equals n minus 2 times 180. N is going to be the number of sides of your polygon. S is what you're solving for. Alrighty, so down here for the example. For a hexagon, which is a 6-sided figure, for the number of sides, which is 6, minus 2, which equals 4, times 180, which is going to be 720 degrees, okay? So the sum of interior angle measures of a polygon, that's a hexagon, is going to be 720 degrees, okay? And you're solving for S, okay? So the same thing for, let's say, even a triangle, right? We all know that the interior angles all add up to 180 for a triangle, but let's just use this formula. So 3, it's a different color. 3 minus 2 equals 1 times 180 equals, you got it, 1, whoa, not 7, holy guacamole, equals 180. Okay? All right, now we're going to move on to the sum of exterior angle. No, we're not. Okay, something else I want you to keep in mind is that when you draw your diagonals, okay, they create triangles, right? So when we draw these out, oh, that's terrible. They create triangles. Okay, so we have triangle 1 here, 2, 3, 4, 5, and 6. Okay, so there are 6 triangles in an octagon, in a regular polygon that is an octagon, right? Create 6 triangles. Well, how many degrees make up a triangle? 180, correct? Correct. So 6 times 180 equals 1080. Okay? So keep that in mind. You could look at this from a couple different perspectives, because this is an octagon, right? So an 8-sided figure. 8 minus 2 would be 6, which is over here. 6 times 180 is going to be 1080. Okay? So just a couple different viewpoints wouldn't kill you. All right, let's do another one. Let's do a 12-sided figure. So 12 minus 2 equals 10. 10 times 180 is going to be 1800. Okay? Alrighty. Let's move on to the sum of exterior angle measures of a convex polygon when we're just talking about one exterior angle at each vertex. So as you saw back here, there we go. When you do that, when you extend the lines, you're actually creating 2 angles, right? You're creating this right here and this right here, so 2. This one we're just talking about one exterior angle, okay? So I took a picture of the chart in the book. So for a triangle, you take your number of interior angles, which is 3. You multiply that by 180. Okay, so that'll give you the sum of measures of linear pairs, one pair at each vertex. Then the sum of interior angle measures. Well, we know that triangle equals 180. So then you take what you just did right here, and you subtract your sum of interior angle measures, and you get 360. All right. So the sum of the sum of exterior angle measures of a convex polygon will always equal 360. Okay. When we're just talking about one exterior angle at each vertex. Okay. So a hexagon. Let's do that bad boy. So we're going to do 7 times. I'm going to follow this chart. So just follow that in your book or on the slide. So 7 times 180. It's going to equal 1,260. Okay. Then the sum of our interior angle measures for a hexagon would be 7 minus 2 equals 5 times 180, which would equal 900. So we're going to take this number right here and subtract this number from it. So 1,260 minus 900 is going to give us, you guessed it, 360 degrees. Okay? When you're doing this work, my suggestion is to keep this chart open just so you can follow along with it. Okay? Alrighty. Our next step here is the measure of angles of a regular polygon. Alright, so the measure of each interior angle of a regular polygon. Again, we're not talking about irregular, we're talking about regular polygons. Whoa, Biscuit, get back here. Regular polygons. So that is going to be very similar to our original formula of n minus 2 times 180. But after we do that, we're again going to divide by the number of sides, or n. Okay? The measure of each exterior angle of a regular polygon is going to be 360 divided by n. So again, in the first steps here we were multiplying, and now we're doing the inverse and kind of going backwards and doing division. Okay, so let's do this. Let's do the measure of an interior angle of a regular polygon. So we're going to find out what each angle is. And it's regular, so all the angles will be the same. So we're going to do an 8-sided figure, so we're going to let's do 8 minus 2, which equals 6. 6 times 180 is going to give us, 1,080. Okay, that final step here, since we're finding the individual interior angle degree, is to divide 1,080 by the number of sides, which is n, or which is 8 here. Okay? Alright, so that means that each interior angle is going to be 135 degrees. Because when you divide 1,080 by 8, you're going to get, bingo, bango, 135 degrees. Okay? Now, to do the measure of an exterior angle of a regular polygon, which is 60 degrees, we're going to find the number of sides. Actually, you know what? Let's do the measure of each exterior angle of a regular polygon. Let's do a decagon. Okay? So now we're finding each individual, let's go to the next page, each exterior angle of a regular decagon. Okay, decagon is how many sides? You got it, 10 sides. So 10 sides, okay, that are all the same length. We're going to do 360 divided by 10, which is going to give us, you got it, 36 degrees. Okay? So that's it. What you're going to do right now is I want you to do numbers 1 through 5. Let's try these. Numbers 1 through 5, all in the try these on the bottom of page 243. All right? Okay, good luck, and I will see you next time. Adios.